Okay, so this is a short introduction on how to use Keil. So first open the Keil icon on the desktop, then choose project from your menu bar and select new project. And then the first thing you should do is to create your own folder on drive D, so give it a name that's unique to you. And inside of that, create a folder for your very first project. We call it IC Project 1. Alright, and inside of that, you can create your project file. We just call it P1, create it. Now you have to choose the legacy support for Keil, and then you have to choose your microcontroller. LPC1778 is what we're using here. Choose OK, and then it asks to copy the startup files into the project. Choose yes, and then you see you have inside of your project a new startup file. Now this startup file is an assembler startup file, so it'll look pretty much unusual to you. We'll explain all about this later in the semester. So for now, you don't have to care about what it really looks like. Now after you've done this, you need to copy additional files into your project. So go to drive D, and there's a folder called MC Tools, and inside of that there's the MC project, and copy all the 4 source code files into the folder you just created for your project. And now you have to add these files to your project, so your project builder knows about them. So right click on the source file group, add existing files, select the 2 C files that are shown, click add, and then click cancel. And then you can actually start working on your project. Now you see in the startup file there's a main function referenced, but we don't have one yet. So we'll have to create another file. So choose add new file and give it a name main.c, and you get an empty file, and just write a bit of silly code in it. Let's see, we create a main function which has a return type of integer, doesn't get any parameters, declares an integer variable I, and just increments that integer variable in an endless loop. Now you have to compile it, so click on the compile button as shown, and take care that no errors and no warnings are shown. So if there are any errors, your object file is not generated and you won't be able to run it. Now the next thing is we want to run it, so we want to debug it. And before doing this, we need to change the properties of the project. So go into properties and then on debug. It's currently probably set on use simulator. You can use this at home to simulate stuff. Running on the real robot needs the uLink debugger, so choose the debug uLink debugger setting, and then you can click the debug button, the red D, and your view changes. And on the left hand side now you see a list of your processor status, so your internal register values, stuff like that. On the right hand side you see the assembler source code on the top, and in the middle you see your C source code. Here you can set a breakpoint, you can add variables to a watch window, so you can actually have a look at the value of the windows at runtime. And so whenever I click the start button, it runs in your while loop until it hits the breakpoint. So every time I is incremented, your breakpoint is hit, and you see your variable I is incremented. Well, that's all for today. That was easy. So you can do single steps, you can step in different ways through more complex programs. We will go into more details on this in the next lectures. So to leave your debugging session, just click the red D again, and you're back into your source code editor session where you can compile again. Please note that it's not possible to compile from the debugger window.